Hi everyone. This tutorial is on estimating the population proportion part 2. In this tutorial we're going to focus on calculating margins of error and using margins of error to determine a sample size. The precision and margin of error. In the previous example, we found that the 95% confidence interval was 0.499 to 0.901. However, this confidence interval was based on a rather small sample size of 20 students. And based on this estimate, we would therefore predict that the population proportion would be somewhere between approximately 50% and 90%. This interval is not really very helpful. It's really too large. We need to find a way of decreasing this interval so that we have a narrower margin. One way of doing this is to increase the sample size. Increasing the sample size will decrease the 95% confidence interval so that we can predict the value of the population proportion with more accuracy. This is illustrated by the next example. Find an approximate 95% confidence interval for the proportion P of primary children in Australia who regularly use social media if we select a random sample of 200 children and find that the sample proportion P hat is to be 0.7. Now in this example, the sample size has been increased from 20 to 200, and so therefore we can predict that the 95% confidence interval is going to be lower. Here is the solution. With a sample size of 200 and a sample proportion of 0.7, my standard deviation is now much smaller. It's 0.0324. So the 95% confidence interval calculated using the same formula is now 0.636 to 0.764. It's a much smaller interval, and based on a sample size of 200, the approximate 95% confidence interval is only between around 64% to 76%. That's only a difference of 12%, a much smaller interval than the previous example, which had an interval of approximately 40%. Calculating the margin of error, the distance between the sample estimate or the sample proportion and the endpoints of the confidence interval is called the margin of error, and we use the letter M to stand for that. For a 95% confidence interval, the margin of error is equal to 1.96 times the square root of the sample proportion times 1 minus the sample proportion, the whole thing over n. If you remember the formula, you will recognise that this is the value that we both subtract from the sample proportion and add to the sample proportion in order to find the lower limits and the upper limits. And we can see from the rule that the margin error is a function of the sample size. Here is the sample size n, and we have to divide p hat times 1 minus p hat by the sample size. So it is true that the margin of error is very much a function of the sample size. So therefore, one way to make the interval narrower, that is to increase the accuracy of the estimate, is to increase the sample size. If I increase this value here, my margin of error is going to be much smaller. Let's look at another example. Determine the sample size required to achieve a margin of error of 2% in an approximate 95% confidence interval for the proportion P of primary school children in Australia who use social media, if our sample proportion P hat is found to be 0.7. This is our solution. We want the margin of error to be 0.02 and the sample proportion p hat is 0.7. We sub 0.02 into the formula for m and we are going to work out the value of n. When this value is substituted in, we find that n is equal to 0.7 times 0.3 times 1.96 over 0.02 squared, and our value comes out to be 2016.84. This means that to achieve a margin of error of 2%, we need a sample size to be at least 2017. Estimating the sample proportion, which we're going to call P asterisk. It's unlikely that we'll know the value of the sample proportion, P hat, before we actually have selected our sample and collected data from it. It's therefore unusual to substitute an estimated value for P hat into the margin of error equation in order to determine the sample size before we even select the sample. However, sometimes we can estimate the sample proportion by basing it on some prior knowledge of the population or even on a pilot study. If we denote this estimated value for the sample proportion as P asterisk, we can now write the formula like this. The margin of error is equal to 1.96 times P asterisk times 1 minus P asterisk over n, where P asterisk is the estimated sample proportion. If we transpose this formula to make n the sample size the subject of the formula, we get the following. If we have a 95% confidence interval for a population proportion P, it will have a margin of error approximately equal to a specified value of m when the sample size is calculated using this formula. So the sample size will be equal to 1.96 divided by the margin of error, the whole thing squared, times the estimated sample proportion times 1 minus the estimated sample proportion. Let's look at an example. We want to determine the sample size required for a margin of error of 2% in an approximate 95% confidence interval when the estimated sample proportion is estimated to be 0.65. So we're going to use the transpose formula. N is equal to 1.96 over m, the whole thing squared, times the estimated sample proportion times 1 minus the estimated sample proportion. We put 0.02 in for m in this formula and then work out the value of n. We find when we do this that n is equal to 2184.91. This means that the sample size would need to be at least 2,185 persons for the margin of error to be 2% in this 95% confidence interval. Now, based on this tutorial and based on the examples that you've looked at, I want you to work on exercise 17D from page 715 of your textbook and concentrate on questions 7 to 10. These questions are all concerning the margin of error for a 95% confidence interval and also finding the sample size required to get a certain margin of error. Thanks for listening.